Hey everybody, welcome to lesson number 7. This is inverse trig functions. These are all the failed attempts at the video that I was trying to make for this lesson. So I think that's what, take number 8 right now. Anyways, so inverse trig functions. We need to know really what the original functions would look like and how they work in order to get the inverses to work, right? Sine, we know what it looks like. It's this wave. It repeats. And we got some pretty important pieces, right? We got an amplitude of 1 to -1. Why that matters is because when we rotate this thing due to the inverse, it's going to rotate basically 90 degrees. We're going to end up having our function looking like this, which is a problem because according to most math, this doesn't work, right? It fails the vertical line test as a function. But mathematicians still want to work with it. They're pretty stubborn about it. So they're like, well, we're going to kind of cheat a little bit. We're going to figure out and cut it to where we can work with it. So they looked at it and they figured if we start from here and travel along to here and stop right there, we're not repeating with that little bit of line, right? If we were to go above it, it starts to come back and it starts failing the vertical line test. If we go below this line, it starts to come back and we fail a vertical line. So if we just get rid of all this stuff and all this stuff and just work with this one piece, we're actually doing fine. And where did we cut that exactly? Well, halfway between pi, so pi over 2, and halfway down to negative pi, so negative pi over 2. That's what we got for a range for sine inverse, which we're going to be calling arc sine. Okay, so this is the range for arc sine. Now, why was I talking about the amplitude? Because that actually carries over for our inverse, our arc sine. The amplitude is still going from -1 to 1, but now we're thinking about this in terms of domain. Okay, why does that matter? Because if we're trying to find the arc sine of something less than -1 or greater than +1, we can't do it because our domain's restricted to those values. So we see something large or really small, can't do it. Cosine works pretty much the same way, right? It's the same general idea of a function, so when we turn it with that inverse, right, it has that overlap problem. So mathematicians, again, said let's cut it. We're going to cut it pretty much the way that we did last time, as soon as it starts to turn back in on itself. But where they were able to cut it this time was from 0 to pi. Everything else we don't have to consider. That's your range. Your domain stayed the same, right? Because we had that amplitude of -1 to 1. It still works here for your domain. It's the same amplitude. Tangent's a little different though, right? Tangent has these vertical asymptotes, which allows your function to start at -infinity and end at +infinity. So when we look at the inverse of tan or arctan, when you start reflecting stuff, now you're seeing that your domain is what's infinite. Okay, so no shortcuts for these, right? Up here with cosine and sine, if we found a domain or if we were being asked to evaluate something out of the domain, it couldn't happen. Here, there's no restrictions, so pretty much everything's fair game. As far as our range is concerned, right, everything's overlapping over and over and over, so they just look at these values here, and they said the rest of this we're not going to worry about. And they cut it at -pi over 2 and pi over 2. So good news is range matches on sine and tangent. Cosine, we're working from 0 to pi. Domain, -1 to 1 for sine and cosine. Infinite domain for tangent. In fact, I have taken time to write those facts down. You should write these down too, in fact. I think this is most useful for this lesson. So take a second to copy those. Okay, we're going to need a unit circle. So if you don't have a unit circle handy, get one loaded on your cell phone, right? Go to Google and type in unit circle. Or if you have the paper copy one from class, you can have that out too. You're going to need the unit circle and this information handy. Okay, how we're going to do these problems. First of all, we're going to check if whatever we're evaluating is within our domain, right? And we know tan, arctan, there's no restrictions. Okay, so that's the first thing we're going to check. Then what we're going to do is we're going to use this part up here that tells us that we can go back and forth between arcs and regular functions as long as we switch the x and y's, right? I had y outside the function and x inside, but now I switch them. Okay, why would we want to do that? Because we know that sine is usually the y coordinate on the unit circle. We know that x is usually the coordinate for cosine, and tangent is a combination of y coordinate divided by x. This one's kind of tricky. But these ones, we just look at the unit circle and decide which one works. What do I mean by that? Let's look at an example. Okay, arc sine of root 2 over 2. I know that I'm able to change that to sine of x equaling root 2 over 2. So what am I doing? I need to look at my unit circle and figure out anywhere that y, right, you said sine was y, anywhere that y is root 2 over 2. And I have it right here, root 2 over 2, positive. That happened at pi over 4, but it happens again too. Happens again over here, we get y is positive root 2 over 2 at 3 pi over 4. Everywhere else it's negative. Right? So here's the ones that we said worked. Pi over 4 and 3 pi over 4. Two answers. So we got to get rid of one of them. Well, that's where the range comes into play. We need answers that are between negative pi over 2 and pi over 2. This is past our range. It doesn't fit. This one, however, is within our range. So this works. Pi over 4 is our solution. Let's check out another one. Arc cosine of negative 1/2. So I'm going to be looking for when cosine, an x coordinate, is negative 1/2. So we look at our unit circle. We're looking when x is negative 1/2. That's positive half. Ah, that's negative 1/2 for an x. That happened at 2 pi over 3. And it happened again down here at 4 pi over 3. So we had 2 pi over 3 and 4 pi over 3. Which one do we want to go with? Well, we need to be between 0 and pi. That's too far. This worked. So our answer is 2 pi over 3. Arc sine of negative 3. Hey, wait a minute. That doesn't even fit the domain. Right? It's outside the domain. We can't even do this problem. This is undefined. Arc cosine of 0. That actually fits inside of the domain, right? It's in between negative 1 and 1. So we can do this problem. We're looking for when cosine is equal to 0. We know cosine is the x coordinate. So on the unit circle, I can see my x coordinate being 0 at pi over 2, and it happens again at 3 pi over 2. Excuse me. Well, only one of these works. Alright, and we know arc cosine is between 0 and pi, so that means that this one does not work, but pi over 2 does. So that's our solution. We're going to look at tangent next. Tangent's a little bit more tricky because we have that y over x thing that we got to worry about. So this problem says arctan of -1. Now I got to think about it. We're working with y over x, right? And we need it to be equal to a 1, -1 specifically. But if I want a fraction to end up being equal to 1, that means I need something divided by itself, right? So when we look at our unit circle, that actually happens. Our x and our y is the same number when we have √2 over 2, right? Same number, y, divided by x. So this should give us a 1. But what we're looking for is -1. So that means one of these has to be negative. Okay, well that happens here at 3 pi over 4. I have one of them as negative. And again, it happens over here at 7 pi over 4. I have one of them as negative. So these two spots, 3 pi over 4 and 7 pi over 4, those actually worked. Right? That's the only time that tan would be equal to -1. Because we have √2 over 2 divided by a negative version of the same number. That gives you -1. Or if this was positive and this was negative, we still get -1, and that was both of these, right? But now we got to think about, what does our range say? Our range says it has to be within pi over 2 and pi over 2. Okay, well, if we were to take this 7 pi over 2 and we were to subtract a full cycle of tan, which would be 2 pi for a period, we would be able to, oops, I had the wrong number, 4, that should be at 4 right here. We should be able to get it down to where we need it, right? Because right now it's outside of our range. But we subtract a full period, which is 2 pi. I'm going to actually change that. I want this to be over 4, so that'll be 8 pi over 4. Once we do that, it'll knock us down, and now we're within our range. So what did I do? Both our answers were outside of the range. We just subtracted 2 pi. Wouldn't have worked here. That would have made us too far. That would have given us -5 pi over 4, which is out of the range. So we had to work with this one, subtracted 2 pi, and now we're in the range. Arctan of -√3. Okay, this one's a little bit different, because now what we're looking for, we're still doing y over x, and we need one of the two to be negative. But what we need is a √3 somewhere. So we look to the unit circle. I can see a √3 over 2 and a 1/2, and I got the 1/2 and √3 over 2. Which one do I want? Well, I'm just going to quickly do that out. Let's say I choose this one with the 1/2 and √3 over 2. I have y as √3 over 2 and x as 1/2. This is kind of like multiplying by 2 over 1. And what happens to my 2's is those eliminate, and we get just √3. So I do know one thing. I need this to be x, the 1/2, and the y to be √3 over 2. But one of them's got to be negative, remember, because we want it to be negative in the end. So I'm going to look at my unit circle, and I see a situation that works, right? Negative and positive, and I got the pieces that I needed in the correct place, right? X was 1/2, y was √3 over 2. So that one worked, 2 pi over 3. The other place that it worked was over, let's see, over here at 5 pi over 3, right? Positive 1/2 and negative √3 over 2. So that worked over here. But we have a problem because, once again, neither of these are within the range. That's just slightly over half and that's definitely over half. So I'm going to work with this one, 5 pi over 3. And I'm going to subtract 2 pi. Really, it's going to be 6 pi over 3 for my subtraction, and we get negative pi over 3. Again, if I tried this one, subtracting 6 pi, that would have given us negative 4 over 3, which is past the halfway mark. So that's why I chose this one. So even if you did this one to start with, it's okay. You'd be able to see that that didn't work, and you move to this one. So we've got a couple for you to try on your own. The first few are arc, sine, and cosine, a little bit easier. So why don't you pause the video, try these 3 out, and resume when you're ready to check your solutions. Alright, let's see how you did. You want to figure out when sine of x is negative 1/2. Or in other words, when is the y-coordinate negative 1/2? That's happening down here at 7 pi over 6, and again at 11 pi over 6. Now, neither of these are within the range, right? Cosine goes from negative pi over 2 to pi over 2. So I'm going to have to subtract 2 pi, right? A full period, a full cycle. And if I do it from here, it's going to be too much. I'm going to have to do it from this 11 pi over 6. 2 pi is what I'm subtracting, but I want it over 6, so I have to multiply this by 6. So that's 12 pi over 6. When I do my subtraction, we get negative pi over 6. Okay, and if you tried doing this one, you'd find that it's too much. It would have been negative 5 over 6, which is past halfway. So there's our answer for that. Next one you had was cosine of negative 2. Brake should have went on immediately and said that that's not possible because that's outside of the domain. Thus, it's undefined. The last one, sine of x needs to equal negative root 3 over 2. So we're looking for when y equals negative root 3 over 2. Let's see, that happens here at 4 pi over 3. And it happens here at 5 pi over 3. Well, only one of those is going to work. We know we have to subtract 2 pi, so I'm going to subtract it from this larger one. 5 pi over 3 minus 2 pi. If I put that over 3, that becomes 6 pi over 3. My subtraction leads me to negative pi over 3. Hopefully that's what you got. Got a couple more for you to practice. I think 2 or 3. 2. Okay, one more arc cosine and one of the arc tangents. So again, pause the videos and check them when you're ready to. Okay, let's see how you did with this. Arc cosine shouldn't have been a problem. You're looking for when cosine equals root 2 over 2. That's positive. It's also your x-coordinate. So we get that happening here, positive root 2 over 2 at pi over 4, and again at 7 pi over 4. Pi over 4, 7 pi over 4. But then you should have checked your range. This fits inside of the range. This does not. So your answer is pi over 4. Arctan, little bit more difficult. This time we have root 3 over 3. Last time we had just a root 3 and we had it in this combo. Right? That gave us a root 3. So what I'm thinking is that if we did root 3 over 2 and 1/2, that would give us this root 3 over 3. Let's check. I want y divided by x. Okay, so really I'm multiplying by reciprocal here, right? Those cancel, and we get 1 over root 3. Hey, that's not quite what I was looking for, but that's also not rationalized. So if we take 1 over root 3 and multiply by this fancy one thing that we've done in the past, we get root 3 over 3. That's what we wanted. So I just explained why we want this look to our coordinates. And we want it to be positive. So in fact, both of these should be positive. So we just need to look on the unit circle and see when we see that. I see it happening here at pi over 6. And it's going to happen again over here at 7 pi over 6 because both of these are negative, and when I divide negative by negative, they cancel out. So 7 pi over 6 and pi over 6. Well, this is outside of the range, so that's out. This is inside of the range because it's between negative pi over 2 and pi over 2, so that's our winner. And that's the end of the video. That's the last example. So, hopefully that wasn't too difficult. If you have questions, bring them in with you to class or leave them on the comments. But the real takeaway from this is just check out your unit circle. Figure out for sine and cosine the coordinate that matches. That's pretty easy. And with tangent, you just have to think about it for a minute. What is tangent equal to? What's the fraction like for tangent? Just kind of mess around with the numbers a little bit. Okay, well, I think we've got one more lesson on trig, and I will see you there at lesson 8.